Welcome back, everyone. Hope that woke you up. All right, so the lab that you see here says housekeeping, DNS, telnet, and SSH. So we're going to do all those things, all right, and maybe a little more, all right, but we're just going to do a network. We're just going to relax, chill out, okay, and we're going to do a nice little network, all right, just 2 routers, 2 switches, and then obviously a PC and a server. Why a server? Because this is going to be like a web server, and it's going to act as my DNS server as well. So we can just change this and put, let's say, web server /DNS, right? It's going to do both jobs, right? I'm going to host my website there, and I'll show you how that's done. But I already have the IPs assigned statically, right? I'm going to click on there, go there. You can see I have 1.1 for the 1.0 network, default Class C mask. Then I have the gateway, last available, as you all know by now with me. And this is wrong. The DNS server is 2.1. Troubleshooting already. All right, and then we'll look at the server and go to the desktop. 2.1, default mask for a C, 2.54, and 2.1. Awesome. So that's done. All right, no biggie. We haven't done anything with the switches. We will. All right, and then in the router, we have the IP address, the show IP in brief. All right, let me open that up a little bit more. All right, so you can see it there. You see my G00, that's going to the LAN. That's my gateway. And this is going through the transit network 10.1.5. That's my IP address there. And then with this one, I'm gonna bring it over here. Okay, open it up a little bit. And then enable show IP int brief. All right, again, let me go ahead and see if I can do this right here. Bring it up here. And then open it up where you can see it nicely. And we'll just like have it up here or something. Okay, all right. So you can go ahead and see there that the LAN G00 for the router is 2.54. It goes towards the LAN and then towards the transit. So we do have connectivity as far as neighbor to neighbor. Okay, we have the ping 10.1.1.5. We can ping there, and then we're going to ping our host 192.168.2.1, and that's not the IP address. Okay, 168.2.1. All right, and we have connectivity there. Cool beans. All right, so let's do some verification first. So let's go to here real quick before we get started with everything. And then let's check out how I did this in the packet tracer. So I click on my web server. I click on the web server for a second time. So I go to services, right? And then I go to DNS. So the DNS needs to be turned on. It's off by default. So the first thing I did was I created globed.net, right? And then I have this address, which is my DNS server address, okay, attached to it. So it creates that A record for me, okay? But what I also did, I created A records for R1. I can create multiple records for R1 because R1 has 2 IP addresses, right? The LAN and the transit, right? The one going out to the other router. And so does the R2. So with R1 and R2, there are 2 IP addresses associated. So I created those A records, right? And it's as simple as just putting it in there. No big deal. All right. So that's what I did for that. And to make it more mine, when, whoops, click the wrong thing. When I go to HTTP index homepage, right? That's the main page. I edit it and I changed it to globed.net. No nonsense, straight to the point education, IP master and last, right? So if I go to the desktop right now and I am in the DNS server, let's go to the web server, or the browser, I should say. I did click on it, believe me or not. There we go. And I type in globed.net. I should be able to resolve that. Okay, so that's why you can play around. You can do email servers on this thing, okay? But you can only point to one DNS server. You can't point to multiple DNS servers. Not as far as I know. If you do know, please put it in the comments. All right, but we don't have connectivity across the network. So the easiest way, the quickest way to do things is to configure default routes, right? We want to go ahead, and the purpose of a default route is, hey, if your routing table, and let's take a look at Router 1's routing table. Let's go here. Let's look at it. Show IP route. So Router 1 has no clue the 192.168.2.0 network exists. He has no idea that network exists. Okay, so he doesn't know how to get to it, right? If I were to ping 192.168.2.1, it's not going anywhere. Let me do the fast forward button. You know me, I'm not very patient. Oh, wrong one. Oh, I was pinging from the router, wasn't I? Yeah, here we go. Okay, so it didn't get anywhere. Request timeout, whatever. Oh, it's really unreachable. At that point, let's do it from the PC so we can see the actual error. Let's go to the PC. Let's ping 192.168.2.1. And I'm getting back a reply from my own gateway. And it tells me destination host unreachable. Because there's no entry in Router 1's routing table. Let me change this because some people may get confused. R1, I don't start from 0, okay? So when I count out, I don't go 0, 1, I go 1, 2, 3. So, and this is R2. Okay, so Router 1 doesn't have an entry for this network. So it'll drop the packet. That's why it said unreachable. It said unreachable. Okay, so what we're going to do is create, you see here it says the gateway of last resort is not set. Well, we're going to create one. Okay, we do config T, very simple. IP route, match any network, match any mask, and just send it to my neighbor, which is 10.1.1.6. Done. That's the quickest and fastest way to do things, right? Let's do a show IP route. There. That's simple. Done. Right? And you have an S with an asterisk that's giving you that. And you see the administrative distance is 1. You can change it if you want. It really doesn't matter for the default route. Unless I've heard students told me that they, in their companies, they create multiple default routes. Remember, default routes are used on stub routers, meaning the end router is one way in, one way out. Okay, and we'll do the same thing on this one. Conf T, IP route, match exactly whatever network you're trying to get to whatever destination network you want to go to. Match exactly the mask of that destination network and just send it to the neighbor, okay? Which is 5. Done. Do WR, show IP route. And there you can see the gateway last resort is set, and you can see it here by the S. So now, if I wanted to, I can come here and I can go ahead and ping now, right? Now I should be able to, I can have connectivity across the network, which is wonderful. Let's see if we can do the website. Okay, so I'm going to say globed.net, and it resolves it, right? Because I have the IP address of that particular DNS server. So it's going to send that packet goes to the server, and it says, hey, I'm trying to resolve through the browser, right? globed.net. So it'll look for that entry in the DNS and then sends me back the website, right? Now, the other host records, where we normally don't pay too much attention to it, and even in the your CCNA, they don't pay too much attention to it, but it's like a lost art. Normally, what I tell people to do is turn off DNS by doing no IP domain lookup, right? Or hyphen lookup. Why? Because if you I'm the typo king. So if I type something like, let's say this is config T to get in, I'll type something like, I don't know, let's say I want to write. Instead of write, I type this, WE. It's going to try and send out because IP domain lookup is on. So it thinks that I'm trying to resolve that name and it's looking for a DNS server. Well, that's not the case. So I do Control-Shift-6. But in this instance, we are. So we're not going to turn it off, but we are going to configure certain things. So we're going to go to global configuration, and we're going to type IP domain hyphen name. We'll call it globed.net, right? And IP name hyphen server, and I'll put the IP address of the actual server, right? Okay, and that's fine. Now, let's test this out. So here I would do it because let's say instead of pinging, let's go here. Instead of pinging, as I want to ping router 2, I know the IP address 10.1.1.6, and I can ping it, right? Or the 192.168.2.254. I know this, right? These are 2 IP addresses that are associated with router 2, but I created host A records for that in the DNS. So if I were to ping R2, I get a reply. And you can see, since I configured it before, it showed a broadcast. Now it's showing an actual DNS server that I pointed it to. So, and it resolves it. So now you can use a DNS, right? You can point it to a DNS server, create the host records, so you can do things by name. I guess in an enterprise network, not everybody's going to know the IP address, right? To resolve something, we're not computers yet, all right? So we're going to do things by name. So this is one way of doing it. Now another way of doing it, okay? Another way, it's statically. Instead of using DNS, you can say. Now remember, look what it did. When I typed ping R2, it looked for the domain server 192.168.2.1 because I pointed it to that. But what if I do something called host tables? IP host 192.168.2.1. Let me do it like an order. I have my way of doing things, right? 10.1.1.6 and 192.168.2.254. So that is called a host table, right? And I can do it for myself as well, right? If I want to ping myself. So I'm going to do WR, but I want you to notice the difference, okay? Do ping 10.1.1.6. It just pinged it, right? It didn't look for a DNS server. It just, okay, because I manually, statically created this host table in the router. It's going to, it doesn't need to look for a DNS server. It's not using DNS whatsoever. So which is better? I believe host tables is more work for you doing it statically, right? Especially in a very large enterprise network. But think about this. Unless you have some, because when you ping by name, you have to go to a DNS server. Once you go to the DNS server, say, hey, listen, I'm trying to ping 10.1.1.6. It's associated, I'm pinging R2. What's the IP address of the host A record R2? Oh, well, it's 10.1.1.6. And then it has to send the information back so then you can ping. Think about what's happening, how DNS is working. So I personally, for small networks, if you have issues with bandwidth, what have you, normally you wouldn't do this across a wide area network. But if you're doing it, say, locally, and you know how to get to things, if you're in, users obviously are going to look for shares. You're going to have map shares already for them, but if not, they can go and look for, the shares that exist in your network. But if you're doing your images out there, you'll have already all the maps, all the shares already mapped, all right, for the users, so they know where it needs to go. It needs to be very transparent to the user. But again, I like to do things based on IP addresses because it's just quicker. Computers don't know names. Computers know IPs. But this is one way or two ways that you can go ahead and ping by name. Either you set up the DNS server, right? Or DNS like we did here, right? What do we do? Here we go. We did, because IP domain -lookup is on. So I said, hey, IP domain name global.net, and the IP name server is 2.1. So I configured that. So then when I pinged the first time for R2, Where is it? Here it is. Ping R2, it looked for the DNS server. When I did a static host table, which was this, and I pinged 10.1, ping R2, I should say. Look what I just did. Do ping R2. Sorry. Oh, it's still using DNS. Okay, so I will need to stop the DNS to do R2. So it still wants to use the DNS even though I know what I did. IP host R2. Sorry. 10.1.1.6. Silly man. Why didn't it give me an error? And 192.168.2.254. There we go. So do WR. Ping do ping. And you guys didn't tell me anything. What's wrong with you? R2. There we go. So now I didn't look for the DNS server. That was confusing because I forgot to put when I first did it, I didn't put the because I didn't put the host name. All right. So if let's do an example again. IP host R1 myself. Okay. What's associated with me? 10.1.1.5 and 192.168.1.254. So if one IP fails, you can try the other one, right? So you can have, I think, up to 8 IP addresses associated with that router. So I'm going to save that, and I'm going to ping R1. Because this time I did put the host name. Oh. Do. There we go. So it's not looking for a DNS server, it's a static host table. So that's DNS and static host table resolution or name resolution, right? All right. So now the next thing that we're going to do is that we did that. Let's see here. So we did DNS. Let's do Telnet and SSH. Well, right? Let's do both. It's the same thing. So we're going to come here. We're going to do it on both routers. Okay. So what we're going to do, we're going to go line VTY 0 space 15, all Telnet lines, password, Cisco, and we're just going to say login. We're not going to do login local, which is, it'll give you a username and password, just login. Okay? And then we're going to say transport, input, and this is where you can say SSH, Telnet, but you're going to say all. It's a lab. I know it's not secure, it's a lab. Okay? So we can try both. Now, in order for all this to work, you do need to put some privileged mode passwords. We're just going to do a basic one, enable password Cisco. All right, just do that. At least we'll have that there. Okay? So let's do that to the other router as well. So that's Telnet, and well, let's finish off to SSH. So for SSH, there's little tweaks that you need to do. So, and you want it to be encrypted, right? Even though you're allowing that, but you need to do IP SSH, authentication retries. How many retries? Maximum is 5, we're gonna put 3. IP SSH, timeout is 120 seconds. That's the max. And then the version, you can do the IP version, IP SSH version 2, right? So it tells you that the keys need to be 768. Now, the only reason we can do, now what we're about to do, which is the crypto, to be able to encrypt, we can do it because we have a host name and we have globed.net, all right? And you'll see it here. So we're gonna do crypto, key generate, RSA, hit enter. It says no less than 768. I'm going to do 4096, the highest possible, and hit enter. Now, what you see here, look what it says. The name for the keys will be r.1globed.net. Okay, so you need to have a host name. You need to have a host name, and you need to have a domain name in order for you to be able to do the crypto keys. If you don't have that, you're not going to be able to do it. All right, so now we're done there. We're cool. All right, and then let's do the same thing on router 2. All right, so enable config T, IP, domain hyphen name globed.net, IP name hyphen server 192.168.2.1. Okay, then we're gonna do the let's do the SSH right now. IP SSH authentication retries. We'll say 3. IP SSH. What is it? Timeout. 120 seconds, and then the version IP SSH version. We'll do 2. All right. Then we're gonna go to the line VTY 0 space 15. We're gonna do password Cisco, and then just log in, and then we'll do transport input all, and obviously the enable password Cisco. So we can go all the way in, right? So that's done there. But we can do the crypto key generate RSA, and we'll do the same thing 4096, and then done deal. All right, we're cool. Pretty simple, pretty easy. So let's test this out. So now I'm in PC0. Let's say I want to telnet, since we have connectivity across the network. I want to, well, let's try both, telnet SSH, right? So telnet, telnet to 10.1.1.6. Password Cisco, CISCO. And then enable, and then Cisco, CISCO. And we're in. So that exit. So let's do SSH. But with SSH, okay, we should have a name, right? So you're like, oh, because look what happens. SSH is going to ask you for a -L, right? If you don't put a -L, when I say put -L, it's going to give you, it's going to error out. Oops, -L, -L, okay. That should be the name now, but I'm just going to put, there is no local username and password. So I'm just going to put the IP address, 10.1.1.6, and it's not going to work. So you need a name for SSH. So you have to do that. So let's just do it for router 2. Okay, not to make this a 3-hour video. Okay, so we're going to do username, LDIS. I'm going to give myself privilege 15, password 0, meaning plain text, Cisco, right? It's a lab. Just so you can see, I'm giving myself level 15 privilege so I can do what I want. All right, do WR. And then I go into the telnet lines, line VTY 0 space 15, oops, because all we said was log in, right? Well, now we're going to change that to log in to local. All right, DWR. So let's try that again. So when we do SSH, -L, right? LDIS, then we put 10.1.1.6. Now it's asking for a password, which is Cisco. And now I'm straight into privilege mode because I have level 15 administrative rights to it. So let me exit out of here. I didn't have to go through user mode, but let's try the telnet. Let's try the telnet, port 23 instead of port 22. So I'm going to telnet into 10.1.1.6. I'm still going to get, I have to type in the password, LDIS, or username, LDIS, and then Cisco. I think I messed up. LDIS, my fingers got cut up, CISCO. And then I'm in, okay? And that's really the way you should do it. It should be login local. People should be logging in with certain privileges so you can do what you need to do. So that is DNS, Telnet, and SSH. So as far as housekeeping is concerned, we'll just do it here on router 1. We already did part of it, which we did the enable secret, enable password, Cisco. You also want to do an enable secret, let's say student, which is encrypted. And then you do the service password hyphen encryption. You want to create a banner, right? Somebody's logging in to you. You do a banner message of the day. Starts with whatever delimiting character. I like money, so I put the money symbol. And I always put stay out. It's gonna be some legal mumbo jumbo that's on there, or letting you know, hey, you don't belong here. If you don't belong here, don't log in. So the banner. The other thing will be the lines, right? The line con 0, right? Line con 0. Password. Cisco. Login. Local also. Okay, you have to use the local. And then we also put login synchronous, right? And in a real iOS, you have the level all for the syslog messages. So these are basic housekeeping things that you should do. Okay, so I'm gonna think of another important one. Am I missing one, Laz? Am I missing one? We did the DNS. I mean, when it comes to NTP, that's something else. Setting the clocks is important. And I think I already did a video on that. But at least this, putting in your passwords, okay, and then encrypting all the passwords, which they are already with the service password hyphen encryption. That's there. We did the telnet lines, down the console line. Yeah, I think it's pretty good. That's pretty good right there. All right. So a very basic lab using default routes, right? Show IP route to gain connectivity across the network because we only have 2 routers. Because you in your test, they can say, hey, this is your topology. What will be the quickest way to create connectivity to your destination network? Would it be using A, B, C, D, E? And it's usually a static route because a default route is a static default route. That would be the quickest way of doing it. All right? You don't want to create a routing protocol, especially between 2 routers. But that's it. If you practice these housekeeping commands, the DNS that I did, and the telnet SSH, you need to practice these commands. It helps you learn the CLI. You get to navigate to different things. Remember, question mark is there to help you. Let me just show you one last thing. All right. Now, we know we have to type config T here. But let's say you're trying to get somewhere and you don't know. Let's say you want to enable CDP. It starts with C. You don't know it's CDP. You can go C question mark. It tells you every command underneath that particular prompt, what's available to you. So you say, okay, CDP. Now, if I do space question mark, it tells me what I can do. Oh, CDP run. Okay. So the question mark, you're not going to get gigged for typing a question mark. You're not going to get gigged for tabbing. All right. It's important. And just remember your basic show commands, right? Show IP and brief. Right, to take a look at your summary of your interfaces, or show protocols, right? That gives you the same information, but you get to see the CIDR, right? You put the right CIDR on there. Show IP protocols. If you have any right? If you have any routing protocols, when you type show IP protocols, they'll come out with the information. Make sure you advertise the right networks. Okay. Show protocols, show IP and brief, show IP route. Okay. Definitely these are things that are basic show commands for you to be able to see what's going on. Okay. Instead of having to type show start and just go all the way down. Cool. All right. I hope this helps. Practice, pause. Here. People ask me, where's the lab? There's your lab. Recreate it. Okay? I'll see you in the next one.